Hello, my pre-calculus student. In this video, we are going to review how to graph exponential function. What makes a function to be an exponential function? If you have noticed, the variable x is on the exponent. So that's why we call this an exponential function. But with this, the next step with this right here, that we create a table that have 7 different values of the exponent, and we substitute back into the function to evaluate. So for example, if the exponent is -4, so we have 2 to the power of negative. So you can see right here, I can do one example. You can see if I do f of -4, what it means is we substitute -4 for the variable x on the exponent. So you have 2 to the power of -4. So since you have two negative sides, it becomes positive. So 2 to the power of 4, and that will give us 16. So we have the first point where x is -4 and y is 16, and so on and so forth. So you can substitute the exponent. You can substitute the value of x on the exponent for -2. So you end up with 2 to the power of -2. That will give you 2 to the power of 2. So that will give you 4. So that will be the next point will be -2, 4. And then the next point will be -1, 2. Now this one, you can see right here that when your exponent is 0, your answers always 1. And the next point will be 1.5. And then 2, 0.25. And the last point will be 4, 0.625. Now we have these 7 points. Let's go ahead and plot them on the graph. So after we plot it on the graph, you can see that the graph is continuous. It means that if you put the pencil on the graph, your pencil just stay on the graph. It doesn't have to jump. Now let's write this down. So you say that this graph is continuous. For all x so we can conclude that our domain be all real numbers. So we will go ahead and use the interval notation from -infinity to positive infinity. And if you have noticed right here that the graph never go below the x-axis. So basically right here, when you see it just approach to the x-axis. So we make a note that the graph never goes below the x-axis. And the value, if you look at your y values, I should say that the y value, so the y values continue up. What do I mean is that the range is from 0 to positive infinity. Now why we have to use the square? Oh, I'm so sorry. Why we cannot use the square brackets? Because the graph never cross the x-axis. So you have to make sure that you do not use the square brackets at 0. Now let's look at the y-intercept. So you can see right here that the graph crossed the x-axis at 1, so the y-intercept is 1. So the y-intercept is 1. Now you can see right here that the at x increasing to positive infinity, the graph approached the x-axis, but the graph doesn't cross the x-axis. So we would say right here that the graph approaches the x-axis, so therefore we can conclude that the horizontal asymptote is the x-axis. Or we can write them as an equation B, y equals 0. Now I'm going to go ahead and show you a new symbol now. So let me just write up here. So we know that at the x value approach negative infinity, the y values approach positive infinity. So how can we translate this sentence into mathematical notation? We will use the limit notation. So we say limit at x value approach negative infinity. So you can see this way, at x value approach negative infinity, the y value, which is the output of this function, the y, and then don't forget to put the function f of x here. The y value will be approach positive infinity. So you can see right here, at x approach negative infinity, the graph, your y value will approach positive infinity. Now let's just look at on the right end. So now on the right end we can see that at the x value approach positive infinity, the y values approach 0. Now let's translate this sentence into mathematical symbol. So limit at x approach positive infinity for the function f of x, the y value, which is the output of this function, will approach 0. This will be the conclusion for this video. Thank you so much for watching this video. I will see you in class. Goodbye.